So the last thing that we're going to talk about for this first day of resistance training are the neural adaptations. Okay, and most of these neural adaptations we've talked about because we've talked about it just in terms of, well, how do we want to increase force or things like that. So should be reviewed, so this should be nice and relatively easy. This should be something we do well on the exam, that sort of thing. If anything's unclear, please ask, don't wait. Okay, so we want to summarize the neural adaptations and explain the benefit of these adaptations. Okay, and so with neural adaptations, we've got several things. So we've got synchronization, recruitment, rate coding, neural drive, autogenic inhibition, and co-activation. Okay, so with synchronization, it's exactly what it sounds like. Okay, so if we recruit more motor units at the same time, we're going to basically ultimately cause the formation of more cross bridges, more force. Okay, but normally that's not what happens, is that we recruit motor units asynchronously. Okay, so it's the tug of war analogy. So let's say that we've got 6 people on a tug of war team, and we number 1, 2, 3, 4, 5, 6, or however you want to do it. Let's just say the first 3 people pull, and then the back 3 people pull, and then the first 3 people pull, and the back 3 people pull. Okay, we're not generating as much force as we can because we're not pulling at the same time. And so with training, what happens is we recruit motor units at the exact same time. And so as a result, we're able to pull or generate more force. So in this case, all 6 of us are pulling on the rope at the same time. So training allows for that to happen so we can generate more force. So then we've got recruitment. Okay, and so recruitment is just exactly what it sounds like. So when we train, we are able to recruit more motor units. So if we recruit more motor units, we recruit more muscle fibers. This causes more calcium to be released, which forms more cross bridges, more force. Remember, cross bridges are always the answer, especially when it comes to muscular physiology. All right. Then we've got rate coding. So resistance training causes an increase in motor drive. In other words, our brain sends out more signals, stronger signals. And so this, what this does is, with rate coding, what happens is not only are we sending out more signals, but we might be able to send those signals out more quickly. Remember, if a neuron is stimulated, has multiple stimuli that allow it to fire successively before the muscle reaches, relaxes completely, it's going to generate more force. More frequent contractions create more force, and then that's also going to last for a longer period of time. Okay, so not only are we sending more signals out, rate coding is when we send those signals out more frequently. So resistance training might help with that. And so this ties into neural drive. Okay, and so this is recruitment, this is rate coding. So this involves both the central and the peripheral nervous system communicating with the muscle fibers. And so if we have increased rate coding, we're going to have less inhibition. If we have less inhibition, we're going to be able to activate more muscles. Activate more muscles, we produce more cross bridges, more force. Resistance training appears to increase our neural drive. Do you remember autogenic inhibition? Okay, so we have got the GTO, or Golgi tendon organ, and their job is to prevent the muscles from producing excessive force. It's I give somebody a heavy box, and instead of trying to carry that heavy box, they just drop it because it's too heavy. We're not trying to injure our muscles. Well, autogenic inhibition, we basically turn off the GTO, and so what happens is we're able to produce greater force than normal. All right, and then the last thing is this idea of co-activation. So when we train, we're increasing activation of agonist muscles. So if I'm doing bicep curls, I'm training my biceps. Okay, what it also happens is, as I train, is I'm turning off my triceps. That'll allow my biceps to generate more force because they're not only resisting the force or counteracting the force of the bar, but they also have to fight the triceps. Well, if I turn the triceps off, okay, they're relaxed and not contracting. It makes it easier for me to move that bar. Okay, so when we're talking about elbow flexion, the agonists are the biceps, the antagonists are triceps, and by inhibiting those antagonists, or the triceps in this case, I will produce more force.